everyone. Today I'm going to teach you about covalent bonding, naming, and simple Lewis structures. So basically just Lewis structures with a single bond. First, we are going to learn about covalent bonding. So covalent compounds bond by sharing electrons so they can both be full. The picture on the bottom right is a really good representation of covalent bonding. The two different colors help show that the oxygens are sharing electrons, and you can also see that the two paths intertwine. In case you are having a hard time remembering covalent compounds are bonded by sharing electrons, I have a trick. My trick ties in with the co in covalent. Most of you have probably been to summer camp and have had multiple counselors. When having multiple counselors, they are called co-counselors because they share the job of being your counselors. This relates to covalent bonding because just like your co-counselors share the job of being your counselor, covalent compounds bond by sharing electrons. Next, let's talk about naming. When naming a covalent compound, it will always start with a nonmetal, so you automatically know that if it doesn't start with a nonmetal, then it's not covalent. Also, the second element in the covalent compound's end will change to "ide". So for example, if the end of our compound is oxygen, then it would be changed to oxide. And lastly, depending on how many of each element there is, you have to change the beginning of the name of the element to what it corresponds with below. The exception is for if the first element in the compound only has one, there's only one of them, then you don't have to change it to mono. But for the rest, if you have two of the element, it would change to di, 3 changes to tri, 4 changes to tetra, 5 changes to penta, 6 changes to hexa, 7 changes to hepta, 8 changes to octa, 9 is nona, and 10 is deca. Now let's do some examples. So we have C4H10. If you look on a periodic table, you know that carbon is a nonmetal, so this is for sure a covalent compound. Next, we look at the 4 with carbon. We know that the 4 means that it is tetra in front of carbon, and with the hydrogen, we have a 10, so that means that it is deca in front of hydrogen. So, our final answer is going to be tetra carbon decahydride. So, now that is C4H10. Now try CS2 on your own. While you do this, I'm just going to quietly sing the ABCs to pass a little time. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Now I know my ABCs. Next time, won't you sing with me? So, now that you've had a little time to do this one, I'm going to show you the answer. So the answer to CS2 is carbon disulfide. So this is the answer because carbon doesn't have any number with it, so it's just going to be carbon. And there's a 2 with sulfur, so we know that's going to be di, and we have to change the end of sulfur to ide, so it changes from sulfur to sulfide. Next, we are going to talk about Lewis structures. When doing Lewis structures, you might want to have a periodic table handy to figure out the valence electrons for the elements. Also, a calculator might be useful to do some of the math that's involved, but it's not horrible math, so it's not crucial to have a calculator handy. So, if we have AsCl3 and look at our periodic table and count across, As has 5 valence electrons and Cl has 7. But we have 3 Cl, so we need to multiply the 7 valence electrons by the 3 we have. So we have 7 times 3 equals 21. And then we need to add the 5 from the As, so plus 5, and we get 26 electrons. Because we only have one As, that will be the central atom with the Cl surrounding it. So it will look like this. As in the middle, and then we have Cl, Cl, and Cl. As you can see, I connected the Cl's and As's with lines, and each line, which are called bonds, are connecting the As's to the Cl's, are worth 2 electrons, and in a minute we are going to start drawing dots that will each count as 1 electron. Now, the goal is to get each to a full count of 8 electrons. As you can see, As already has 6 electrons because each bond is worth 2, and our Cl's have 2 electrons. So now we are going to put some dots in to try to get them all to have 8 electrons. So we are going to minus 6 electrons because of our bonds, and we have 20 electrons left. So we are going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19 and 20 are going to go on the As, the central atom. So now we have used up all of the electrons, and each element has 8 electrons on it. So this is the Lewis structure for AsCl3. Now try this one on your own. So the problem is SiF4. And so while you do this one again, I'm going to quietly pass the time away and sing the ABCs. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Now I know my ABCs. Next time, won't you sing with me? Okay, so hopefully you have finished this problem or are close to being done, but I'm going to go over it for you. So Si is going to be the central atom because we only have one of them, so with the F's surrounding it. So we have Si with the bonds connecting the F's to the Si's, so we have 4 F's. And so if you've looked at your periodic table and added it up, you should have 32 electrons, and if we minus 8 for the bonds, we should have 24. So now we are going to add the dots onto the F's and see if we get 24 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So like the other problem, we have all of our electrons onto the Lewis structure, and all of the elements have 8 electrons on it, and it is full. So this is the Lewis structure for SiF4. This also concludes my video. Thank you so much for watching. I hope you have a great day. Thank you. Bye.